Hi everyone! In this video, we will be learning Chapter 2, Force and Motion 1. So, through this video, we will be emphasizing on the subtopic momentum. Before we start our lesson, you should know that by the end of this video, you should be able to apply the principle of conservation of momentum in collision and explosion. Okay, let's move on to principle of conservation of momentum. The word conservation means that the value is unchanged or remain the same. Okay, now let's look at the principle. When two bodies act on each other, or we can say when two bodies collide with each other, their total momentum remains constant if no external force acting on them. Now let's see an example here. As you can see, two cars are about to head-on collision with each other. So, external force means force from outside of the system. Okay, so this is the system, and then we have force from outside. That is external force. Example of external force can be normal force, weight, frictional force, or air resistance. Okay, we will be focusing on external force in other subtopic. So, during this collision and after the collision, we must know that the total momentum before collision is equal to total momentum after collision. So, you need to understand this one. Total momentum before collision is equal to total momentum after collision. For collision, there are two types of collision, which are elastic collision and also inelastic collision. So in order for you to understand the situation of each collision, I will divide the situation into two parts, which are before collision and also after collision. Okay, we will be focusing on the elastic collision first. Okay, here you can see an object A with mass A and initial velocity of A will be colliding with an object B with mass B and initial velocity of B. So at some point, they will collide with each other, and their situation after collision is that they will be separated from each other. Okay, their mass remain the same, mass A, but their velocity now is final velocity of A, and then here is the final velocity of object B. For inelastic collision, the situation before collision are the same with elastic collision. At some point, they will collide with each other, but after collision, they will combine and move together. Okay, as you can see here, object A and object B, they will be sharing the same final velocity after collision. Okay, as we already know the situation of each collision, now let's move on to the differences of each collision. Okay, for elastic collision, the object moves separately after collision, as I shown just now. Momentum is conserved. Okay, and then kinetic energy is conserved. Total energy is also conserved. Now let's look at inelastic collision. The objects may combine and move together after collision. Momentum is conserved. Kinetic energy is not conserved. And total energy is conserved. So as you can see here, for elastic collision, the kinetic energy is conserved, while for inelastic collision, the kinetic energy is not conserved. Okay. Another event that has linear momentum is explosion. For example here, an object is being fired from a cannon. So you can see here, this ball is being fired out of the cannon and it moves to the right. Then this cannon will recoil to the left. It will recoil to the left. So in explosion, the total momentum is conserved, which we can say that the total momentum before explosion is equal to the total momentum after explosion. So this is another part that you need to remember. Now that I have already explained to you what is momentum and the principle of conservation of momentum, let's do some question to test your understanding. Okay, you can pause the video to read the question first. Okay, in order for us to solve the question, we need to know the situation before collision and after the collision. Now, I put there before collision. We have a 0.5 kilogram ball. So I just put there ball A, mass of ball A, traveling at 6 meter per second. So the initial velocity for ball A is 6 meter per second. Collides head on. This one means that the collision is elastic collision. Okay, it collides with a 1 kilogram ball, another ball. So I put it as mass of ball B, 1 kilogram, moving in opposite direction at a speed of 12 meter per second. So the initial velocity for ball B is negative 12 meter per second because it moves opposite direction. Okay. And then this one is the situation for before collision. Now the situation for after collision. So after collision, we still have mass of ball A 0.5 kilogram. And then this ball A, after collision, it moves backward 14 meter per second. So the final velocity for ball A, negative 14 meter per second. Find the velocity of the second ball. Velocity of the second ball after collision. So this one is final velocity of ball B. Okay, so we put there mass of ball B 1 kilogram and we want to find this one. Okay. Okay, from the information given by the question, now you can apply the principle of conservation of momentum, which total momentum before collision is equal to total momentum after collision. Then you put in the formula and then you put in the numbers. So here we want to find this one, the final momentum of the final velocity of object B after collision. So you simplify the numbers and then you get the final answer is negative 2 meter per second. Okay, so this one is the answer for question 1. Let's move on to question 2. Okay, the question says a bullet of mass 12 gram is fired at a speed of 360 meter per second from a rifle of a mass 6 kilogram. Here are the figure. And then the question is, A, what is the recoil velocity of the rifle? And then B, the bullet travels towards a block of wood resting on a frictionless surface. The wooden block moves with a velocity of 12 meter per second after the bullet embedded in it. Calculate the mass of the wooden block. Okay, actually, this question consists of two situations, situation A and also situation B. Okay, let's look here. Situation A asks, what is the recoil velocity of the rifle? So here, this one is the situation A. This situation A is actually talks about the phenomenon of explosion. Here is explosion. While B, the bullet travels toward a block of wood. B is this part. Okay, this part, which is actually the situation of collision. But which collision? Is it elastic collision or inelastic collision? You can see here, after the bullet collide with the wooden block, the bullet embedded in it. So this means that this one is inelastic collision. Okay, let's solve for part A first. The recoil velocity of the rifle. So this situation, this one is an explosion. So we need to know the situation before explosion. Okay, before explosion, we have the mass of bullet, which is 12 gram. So we need to convert to the SI unit, kilogram. And then the initial velocity of the bullet is 360 meter per second. Okay, for before explosion, we no need to consider the initial velocity of rifle as the rifle is at stationary for before explosion. And then now, after explosion, we need to consider the mass of rifle as the rifle recoil after the explosion. So mass of rifle is 6 kilogram. And then we want to find the velocity of recoil of the rifle. Okay, this one. And then at this point, after explosion, we will not consider the velocity of the bullet, as the bullet will shoot at the wooden block and it will stay stationary after explosion. Okay, applying the principle of conservation of momentum, this one, total momentum before explosion is equal to total momentum after explosion. Okay, you need to write the formula and then you put in the value. Okay, we will find this one, recoil velocity of rifle. So the answer will be 1 meter per second. Okay. Okay, as for part B, this one is the situation for part B. Okay, as usual, we need to find the information for before collision. We need to find the mass of bullet and then the initial velocity of bullet, 360 meter per second. Okay, for before collision, the block of wood is resting on a frictionless surface. So it means that the block of wood does not have initial velocity. So we don't need to consider. Now we need to find the information for after collision. So after collision, mass of bullet is that 0.012 kilogram. And then mass of wooden block, we want to find the mass of wooden block. And then this one, the velocity of both wooden block and bullet is 12 meter per second. Okay, applying the conservation of momentum, this one, and then you put in the formula. Okay, and then put in the amount. Now we want to find the mass of wooden block. So mass of wooden block will be 0.348 kilogram. Okay, I hope you can try this exercise. So that's all for now. Thank you everyone.